Hello everybody, how's everybody doing? Hope you're doing fine. First, I want to remind everyone one more time, we have a conference coming up in Lusaka, Zambia, and some pretty interesting people always show up. So if you want to have a good time, you want to have an exotic vacation, short vacation perhaps, meet an exotic land, well, this is your chance. You want to meet Africa, this is it. I've been to Northern Africa, Morocco and Egypt and so on, but I've never been in South Saharan Africa. And for those of you who are a little scared, you say, well, I don't know about these lands. Here's a couple pictures from Lusaka. There's the skyline. Yeah, not so bad. I mean, it's civilized. Okay, so don't be so afraid, okay? If that's what keeps you away. I also want to remind everyone they can download the book we uploaded the other day to the site. You go to ropehypothesis.com, and if you go to books, you'll find this book that's been there now for over a week at least, and you can download it for free. It's a 160-page book. It puts you up to date, brings you up to speed on the rope hypothesis. Okay, so for any of those who have a second language and master it, maybe mother tongue or whatever, here's you can help me translate some of the book to different languages. We're in the process of translating them now, and if you know a different language, you know it pretty well to be able to do a translation, right? We do a Google translation first, and then you just kind of go in there with your little brush and fix it up a little bit. And yeah, please mail us at tokakaka@hotmail.com, and we'll be glad to send you the Word file for you to translate, okay? Anyways, I had a lot of comments this time around, so I'm going to do my best to get through them today because there's a lot of issues to address. Some of the things people don't understand. Other issues are questions people have in their minds, certain things they can't figure out or answer, or they cannot visualize, and it's important to clarify those things before we move on. Okay, so let's go with the first comment that I received, or one of the comments that I received. We can't see space because all spots on the night sky, including dark zones, are loaded with electromagnetic threads. This notion that, several people have over the years, said this, whether it's whether the threads cover the entire space, and we're looking at threads, and since we can't see the thread, then we're looking at space, but we're actually, our eyes are hitting on all kinds of threads out there. And the answer is no. The answer is if space were a physical object like an ocean, there would be more ocean than threads, okay? And here I'm going to put it in a little picture so that you can see what I'm talking about. Here's the two galaxies, okay, and they're connected by ropes, okay? And so every atom in one galaxy is connected to every single atom in another galaxy. That's the theory, okay? And that's the hypothesis. From there we derive theories of gravity and light and so on. So you can see that in order for there to be ropes, each rope has to be enveloped or encapsulated, any way you want to look at it. It has to be covered in space, okay, so to speak. And so yeah, there is more space between two galaxies than there are ropes. Okay, electromagnetic ropes, which is what we are proposing. Okay, we're saying that every atom in the universe is interconnected for those who just dropped in and don't know everything of what this site is about. And here we stretch the galaxies farther apart. Okay, so now you can see what happened to the ropes. The ropes here were a little more wide as they reached the galaxy. And here you can see that it becomes almost like a single coaxial. They all kind of merge. The greater the distance between galaxies. And here's how we would see the Andromeda galaxy from our galaxy. Our galaxy is that one on the lower right, and we see it almost as a single dot in the sky. I mean, we can't see the Andromeda galaxy at all, and it's bigger than our entire Milky Way galaxy, and we can just barely see this galaxy. In fact, if you put your eye there, that's what you would see. You would see just a little dot. Why? Because all those ropes come in as a single coaxial. They're all bunched up together. They act as a single one almost. That's why gravity is so weak at such great distances. It acts as like a single coaxial. Okay. Another comment. So the point there, there's more space than threads or ropes, right? Much more. If we look at space as a volume of something, space under the rope model is nothing, absolutely nothing. What does nothing mean? Nothing means that which has no shape. In contrast, the rope does have shape. So we have something that has shape, and it's not inside, it's not in, it's not within, because there is no container called space. Space is nothing, that which has no shape. Not even God can cross space because he has nothing to cross. There are no borders to step across into another universe. No such thing. Not even God can cross space. Beside the fact that he would lose his shape, because it's space that would give him shape. Okay, and here we have another comment. It says, I used to like your rope theory because it makes sense. Good. But seeing today, putting math and theoretical physics under religion and philosophy under science doesn't make sense anymore. I understand they're not perfect, but it's testable. Whoa. And works for now, okay? Unlike your theories, test them, make predictions on them. I can't follow this channel anymore. I like my head without a tinfoil hat. Love that one. Okay. Let's see if I can get my reply up here. Here's my tinfoil hat. Okay. And so what do we answer? Well, the first issue is that it's not a rope theory, it's a rope hypothesis. And obviously this individual is just went through there superficially. And because of that, he just kind of, it happens to many people. They come here and they say, oh, rope, I like that idea. All the atoms are interconnected. Okay, that sounds nice. But when they go in a little deeper, they find, they hear things, that they don't want to hear. And what this site is about primarily is this paradigm shift on the scientific method. Okay, we have a new way of looking at science. We're saying that anything that happened at least as early as the 17th century, so-called 17th century scientific revolution, all the way to today, none of that is science. Okay? We dismiss that as religion. This is what they did, is religion. Science is something else. Science is explaining mechanisms rationally. You have to, as applied to physics, okay? You have to explain a mechanism rationally. What do I mean by rationally? That you don't move concepts around. What have they been moving for the last 400 years? Well, they've been moving waves, which are concepts. There's no physical object called wave. They've been moving mass concepts, like moving weight around, You don't move weight. You move the elephant, not the weight of the elephant. Okay? You don't move singularities. You don't move the center of masses. You don't move energy. You don't move. You don't transfer information. We don't transfer information or catch it. I don't know. I've never played baseball with information. It's always been with a ball. And so on down the line. We don't use force. We don't use field. We don't use time. All those words have nothing to do with science. And so when you start moving those around, start warping time and traveling through time and treating time like a medium, then that's not science. We call it religion. And it's the worst kind of religion. We can all imagine God. What we cannot imagine is four-dimensional space, time. Okay? So that's where we run into trouble with all this. So yeah, there's been a paradigm shift on the scientific method, and science is rational explanations. And the reason math, let me put this guy back in there. The reason he objected, he said, putting math and theoretical physics under religion. Yeah, exactly. Math has nothing to do with physics or with science, because math can only describe. Physics explains. Now, I have not put math in religion. I put mathematical physics in religion. What is mathematical physics? Mathematical physics is the physical interpretations that the mathematicians derive from their equations. That's something else. Math is one thing. It's a language. It's not even part of science because it's a language of descriptions. In science, we don't describe. In physics, we don't describe. We explain. We explain a mechanism. That's what we changed. We're saying, and we had to change it because no one has defined the word science in the last 10,000 years, and we'll get into that in a minute. But here, the issue is that we have no definition. First, we had to define it, and second, the definition that everybody uses informally has to do with descriptions. They include math because mathematical physics gives irrational explanations as a result of interpreting their equations in terms of particles. That's what the problem is. The problem is particles. We cannot explain a single phenomenon of nature, invisible phenomenon, with particles. Okay, you cannot explain it with particles. And they've been trying for the last 400 years. They finally gave up on particles, on real particles, on what they call classical particles. They gave up on that at the turn of the century, of the 20th century, right? First quarter of the 20th century, they changed all that, and the particle became the word. They continued using the word particle, but that particle was not a particle. It was a concept. It was an abstract concept. It was a vibration of a field. In those days, it was a bundle of energy, and then somehow today it's been converted into an excited field. So what we have today, when they talk about a particle, they don't mean a particle. They don't mean like a speck of dust. That's not what they mean. They mean there's a vibration of a field. Okay, and this vibration of a field somehow travels at great speeds. They can't explain that because that's when they use the particle again. They forget about the field, because the field is supposed to be like an extended web that covers the entire universe. And they say that's essentially what we have out there. And then when the field vibrates locally, that we see it as a particle. Okay, so how does the particle travel if the field is vibrating locally? And that's when they get rid of the field, and now they continue with the particle. And they say, now the particle, now they treat it as a little ball, and now they continue with a little ball and say the ball travels at 300,000 kilometers per second, or whatever, at great speeds. And this is the problem. The problem is they don't have a physical interpretation. And most people out there that are rational, that have a head on their necks, they want an explanation of how gravity works, how a how a magnet attracts another, what electricity is, how the atom works. These people want qualitative answers. They want explanations that they can visualize and take home with them, and they say, okay, I see what you're saying, and they can visualize it, understand it. Right now, people don't understand nothing. They can't understand anything coming out of the establishment, and the only conclusion all these people say was, thank God that someone understands all that. We have all these great minds out there from Cambridge and Harvard who can interpret all that math and understand what's going on there, because I don't understand squat. And it turns out that all these invisible mechanisms are kid stuff, are kindergarten stuff. And you say, you're kidding, Bill. No, I'm not kidding you. It's more difficult to explain how a car runs than to explain how gravity works, the mechanism, okay? The mechanism of gravity is kindergarten stuff. once you figure out the invisible entities that mediate gravity. Why does, here we have a pen and it falls to the floor. Okay, so it falls always. You do the experiment a million times if you want to be satisfied. You let go of a spoon, you let go of a fork, of a baby, they all fall to the floor. Okay, and you say magic because you can't see the meteors. That's the only you can't see what agents are mediating that invisible transaction. That's the only reason it's mysterious, and it sounds like, oh, we'll never figure it out. It's dumbfounding. It's over my head. No, it's very easy. Once you make the invisible agents, the mediators that Mother Nature uses, it's kid stuff. It's baby stuff. It's for kindergartners. You don't need to take any math. You don't need to. All you need to do is understand the mechanism once you see the visible, make the invisible visible. That's all it is. And so what these people have done is try to figure it out through math, through equations, through particles, through experiments. And of course, none of those are the route. None of those are the path to understanding how Mother Nature runs her invisible stuff. That's what it is. And so, yeah, we don't need any math. And yeah, people get upset when you say that because they say, oh, for 400 years we've been using math and now you're telling us that we don't need math? Sorry. Yeah, we never needed math. That's why none of these people can explain it, because they've been using math. They've developed math to ridiculous levels, and today we have no explanations whatsoever for the simplest mechanism. And I'll get to that in a second here. Anyways, in science we don't do any testing. Let me put this back up here so you can follow along. It says, I understand they're not perfect. Perfect. Who was it? Anselm, who talked about perfection of God, and he proved God through perfection. But it's testable. Well, in science, we don't test anything, okay? It's technology that tests and works, okay? So if you're talking about testable and working, you're talking about something else. You're not talking about science, okay? And then test them, make predictions. In science, we don't make predictions. Sorry, that's astrology. You're in the wrong field. We don't do predictions. It's math that introduced predictions in great measure, because once you have an equation, you can say, well, how fast is the car running? The car's running at 50 miles per hour. Good. That means that if nothing else changes, if everything continues like that, in 1 hour, that car will be 50 miles away. So you can predict with an equation. What have you explained? You haven't explained anything. All you did was make a prediction. What is a prediction? A description. That's all it is. So you described that a car is going to be instead of at point A, it's going to be at point B in 1 hour, because if everything else is equal, traveling at 50 miles per hour, it'll be at 50 miles away from A, which is at point B. So you can predict. That doesn't tell us anything. That's good maybe for technology, which is a bigger story still, but for sure, you're not explaining anything. Explanations, you got to explain a mechanism, and that's not what mathematical physics, so-called science, does. And yeah, so people get upset when you say math has nothing to do with physics, and neither that which works. We don't care if it works or not. Computers work not because quantum mechanics is rational or even correct or anything, or because they understand it. No, they work. Computers work because we develop them by trial and error. You try one thing, it doesn't work. You learn from that, and you say, okay, next time I'll make it smaller or bigger or longer or higher or whatever. You change something in what you did. You still don't understand. You just try one thing right after another until you get it right. Who was it? Thomas Alva Edison. He said, I haven't failed. I've tried, I just found 10,000 ways that don't work. And that's a synthesis of technology. Anyways, he says, I can't follow that. I like my head without a tinfoil hat. Yeah, okay. But he said, anything related to opinion, like, I don't like this, and I think you're wrong or right. All that has to do with religion. That's opinion. That's your personal opinion. So none of that enters science, okay? Okay, let's move on here. Here we had another comment. Okay, and individual says, I hope he continues to promote the rope theory. That's interesting because he says rope theory the same thing as the other guy. Now it's known as the rope hypothesis, okay? And people don't understand the difference between theory and hypothesis when they say that. Okay, theory is an explanation. Hypothesis is an assumption. An assumption is not an explanation. And not everybody understands that. That's part of the change that we've got. The assumption only carries for the purposes of physics, okay? Here I'll summarize it with a little bit here so that you can see what I'm talking about. Okay, the assumptions only include the objects, the definitions, and the initial scene. Again, I give the example, detective goes to a crime scene. The first thing he wants to look at is what were the objects, like a knife stuck to a person's back, the person dead on the ground. Those are the objects. Maybe some fingerprints, blood, whatever. Definitions, you need to know what a crime is, what stabbing means, what, the different words that you use in that business, in the detective business. And then you describe the initial scene. That's before you can tell us what you think happened, which is the explanation of the event. Okay, so that's what a hypothesis is. It's a set of assumptions, and the assumptions include the objects, the definitions, and the initial scene. The first few frames of the film, the film strip. That's what it is, of what you saw. Okay, the staircase, the lamp on the floor was crooked, whatever you saw, you set the scene so that people can visualize that. And from there, now you can build your theory on top of that and say, look, this is what I think happened. That's the way it works. And these people don't understand that. They think that a hypothesis is a theory that has no evidence, or it's a speculation. It's a speculatory theory. So they have no provision for the objects, for the definitions. They have no provision for any of that, or for the initial scene. So that's the problem. The problem, they have no provision for assumptions. They go directly into the theory and they say, oh, we're already in the theory. You missed the assumptions. Assumptions, we don't care about those, So yeah, this is a big part of the problem. Most scientists disagree with Bill's definition of science. Well, let me put a little something here on the side so that you can follow along. Give me a second here. Got so many of these, Yeah, first one, tongue-in-cheek, that he thinks it should be promoted. No, these people are not into promotion of the rope hypothesis. Whether the scientists disagree with my definition, science is not democratic. You don't get to vote for definition. You don't get to vote for definitions. Like you don't get to vote for whether God exists or not. I mean, people do, but that's religion on both sides of that divide, right? In other words, in science, what we do, we try to find the best definition we can for a word that's crucial, that makes or breaks a theory. And people have to get in the ring with their shield and with their sword. They have to fight for their definitions. And if they can't defend their definition, they get out of the ring. They lost. So this is not an issue of voting and saying, oh, that's not what we always called science. First of all, we have no definition of science, okay? And that's another issue we should mention to those people who have just pounced upon this channel. Let me put this other one here. Let's continue with this one. What the hell? These are the definitions you'll find out there. You'll see the first one, I think, was from, the second one was from the Wikipedia. The first one is one you'll find on the internet. I can't remember what the site was. Then you have NASA at the bottom. And the first one says, systematic study of the structure and behavior of the physical and natural world through observation and experiment. The second one says, organizes knowledge in the form of testable explanations and predictions. Well, obviously those two are very different. So we don't have a definition from the official world out there, establishment, on which they can agree. They have no idea what science is. And then you have NASA there. It says science consists of observing the world by watching. Oh, great. So you gawk and you're a scientist. So yeah, we got a problem because these people are saying, that first of all, they have no idea what science is. Okay. And so, yeah, it's not a question of saying that you disagree with my definition or that all the scientists disagree, because, right now we have no definition. Okay, let's get this one back in there. Okay, so what's the issue? The issue is that this individual says he even manipulates language to suit his definition. No, you whether you manipulate or not, you have to define the terms. Okay, that's the issue. So so you must define the terms. Here it is again. Okay, you have to define your terms because you're going to be explaining a mechanism if you're doing physics, and you need to know what words to use. If you're going to define the word object and or you're going to use the word object, or you're going to treat things as objects, you better know what an object is. And if you can't define the word object, or you have a different definition, well, we had better know what you mean by the word object if we're going to follow your presentation. Okay? And then in ordinary speech, form equals shape, but in physics they are the same. Okay? Yeah, that's what I'd say, and he's quoting me there. Okay, he says if he can't explain the universe with ordinary speech, then he should be explaining should not, I guess, be explaining anything at all, and he belongs in the same category as the scientists he denigrates. Well, the issue is that whether you in physics we only have shape and no shape. Okay, that's all we have: shape and no shape. And for all people who want to challenge religious folk, traditional religions, it's very easy. You just ask them not whether God exists or this or that. Ask them whether God has shape or has no shape. Is God an object or is God a concept? Okay? I mean, if God is love, intelligence, information, whatever other word you can think of, energy, then God is a concept. And that's what you're praying to, a concept. If, on the other hand, God has shape, he's an object. And that's the way we treat these words in physics, science in general, right? And so, yeah, we have to define it, and we define it in terms of shape and no shape. Now, he wants to make a distinction between form and shape. Many people like to do that because that's what they learned in ordinary speech when they went to high school, college, or whatever. And so they say, well, form is not the same thing as shape. That's their notion. And they say shape applies to something like, a 2D figure, like triangle. Whereas form is applicable to something that is 3D or three-dimensional. Okay? And so we have several problems there, because that means you're not defining object, you're saying that there are different kinds of objects. There are 2D objects and 3D objects. That's one issue. So you still haven't distinguished, you haven't defined the word object by distinguishing between form and shape, okay? So it doesn't really matter in science. But then there's the other issue. You have 3D shapes, such as cubes, perfect ideal cubes. There is no such thing out here standing called a cube, perfect one. Right? And so what do we do with those? Where do we put those? We put them under form or under shape, because you can only see a perfect cube. You have to imagine it, because all they can do is project it onto 2D. Okay? You can't have a 3D cube, a perfect 3D cube out here. And even if you do it with a hologram, you can't get it. You can't get a perfect cube, no matter what you do. And so we don't have perfect cubes in the real world. They don't exist. And so, again, we're talking about different kinds of objects, and you haven't distinguished between shape and form, at least for the purposes of physics. So, yeah, no, that doesn't work. And again, what this individual has to do, he's got to define the word object in the alternative. You got to give me a definition, something we can sink our teeth into. And then he says, if Bill wants to call rational science that part which I refer to as interpreting the results obtained through experimentation, observation, that is his prerogative. However, that is not the definition of science. And again, we have to fight for our definitions. It's not that we simply accept them because of tradition. Okay, because that's what our teacher told us. That's one issue. But then here we have another issue, and that's what he's saying here. He's saying, experimentation. He says, however, that is not the definition of science. That is only a small part of a scientific process. Process? I mean, what is he talking about? First of all, we have no definition of science. Second, what does he mean by process? Process of what? I mean, what is science? What does he mean that science is a process? Is it a process of learning? That's it? Which is what we do in school. We just memorize a poem and we're scientists because we learned. We made progress in our learning. Science has to serve some purpose. You can't just say that science is, whatever everybody's been doing so far, because as I showed a minute ago, we don't have a definition. Okay? And then we have the issue that they have no explanations for almost anything. Here we had the other day, I'll put it once more up here, Mr. John Bias and his crackpot index, and he says what? He says 10 points for arguing that while the current well-established theory, meaning general relativity and quantum mechanics, right, predicts phenomena correctly, it doesn't explain why they occur or fails to provide a mechanism. Yeah, these people are not into mechanisms at all. They're not explaining mechanisms, so we're never going to find out any qualitative stuff. We're never going to find out how gravity works, but because nobody's working on it, and nobody's working on it or gets funds or for research or whatever, because it's not a part of science according to them. So this notion that this individual has that, little by little we're going to approach knowledge or we're going to be doing studying forever until we figure it out. He's totally out of his mind. Okay, nobody is investigating these issues. Let me put this up again one more time. This is Niels Bohr and his crew here. Susskind, Leo Susskind, professor from Stanford University, and Richard Feynman, which a lot of people know. He was a Nobel Prize, 1965, I think it was. And these people tell you they don't understand their theories. That's what they're saying there. And I'll just read the last one again. I think I can safely say that nobody understands quantum mechanics. Nobody understands quantum mechanics. Please read my lips. Do not keep asking yourself if you can possibly avoid it. How can it be like that? Nobody knows how it can be like that. The more you see how strangely nature behaves, the harder it is to make a model that explains how even the simplest phenomena actually work. So theoretical physics has given up on that. Nobody is doing qualitative stuff. Nobody in quantum mechanics, at least, right, is trying to understand mechanisms. That's over with. It died at the beginning of the first quarter of the 20th century. Nobody is doing that anymore. And people don't understand. They say, no, we have computers. You wouldn't have a computer if quantum were wrong. They say stupid things like this. Or you wouldn't have GPS if general relativity were wrong or relativity were wrong. They say stupid things like this. And no, they have no idea of the mechanism. They try one thing, they try another until they figure it out, and then now the technology develops. That has nothing to do with knowing what a magnetic field is and how a magnet, what the mechanism is between two magnets for attraction or repulsion. So people don't understand that. That's what they haven't figured out yet. None of that. And we haven't figured that out despite all the math and despite 3,000 years of brainstorming, all kinds of nonsense since the Greeks all the way to today. Okay. And here we have another set of questions here, or issues. The essentials of science, this individual says, evidence gathered in experiments and observations. So is that what science is about, evidence? Who introduces evidence? I thought it was the prosecutor and the defense attorney. Aren't those the guys who introduce evidence in a courtroom? Why do they do that? I mean, why would anyone introduce evidence? Well, they introduce evidence because they're trying to persuade and convince the jury to get on their side of their case. They're trying to convert them. They're trying to recruit them to their side of the battle there. That's why you introduce evidence. So evidence is there only to persuade and convince. Evidence has nothing to do with science. Science, we have to explain a mechanism objectively. Whether you believe it or not, that's your personal business. It doesn't concern science. You might like the theory and say, oh, I like that theory. I'm going to take it as mine from now on. Fine. That's fine. That's your religion. Has nothing to do with science. That's your opinion now. You know, the fact that someone explains that angels, move the curtain around, that's his theory, right? You say, yeah, I like that theory. I like the angel theory. So he convinced you, he said, look, every time I stand here, the curtain moves. That's the spirit of my great-grandma that's moving it. And yeah, maybe he should just shut the window. I mean, but the point is, someone believes the evidence, whatever evidence is introduced there, and says, oh, I believe in the theory. Well, that's his personal business. He believes in the theory. We just care about the objective explanation. How did the curtain move? Well, this guy says an angel did. The other guy said, no, a bunch of particles hit the curtain. Another guy says, no, it was waves, all these fields that extend all the way to the edge of space-time. So they have all these different theories, and we're interested in knowing what each one has inside his head. We want to hear mechanisms. Then you choose which one you think is best for you. But when you say, well, let me prove it to you. Now you're twisting arms. Now you're introducing evidence to persuade, to convince me. That's why evidence has nothing at all to do with science, and that's why the mathematicians, the mathematical physicists, they've been introducing evidence. Why? Because they're more interested in persuading than they are in explaining. Because they know they can't explain, as you just saw. They don't understand their own theory, so they just introduce evidence to prove to those people who are not, very well versed in mathematics and in physics, in issues of physics. And yeah, they're just trying to recruit them. That's all it is. They're trying to convince them, yeah, I know. See, look, I can explain it. Here's the evidence. And then they tell you a particle can be at two places at once, or that time can be warped. And so when you look at those explanations, you go, well, something's wrong here. I mean, how do you know? And when you push them against the wall, people who know a little more about physics, these people say, well, we don't understand how this universe works. But that's not what the people out there believe. The layman believe that these guys know, because otherwise we wouldn't have all this technology. That's their reasoning. And this is the problem we have. We have this circular thing going on in society where we have these mathematicians. They tell you in your face, we don't understand our theories. The other guys say, well, yeah, you do, because otherwise we wouldn't have the technology. And when you try to question them, they say, no, we don't understand it. All we do is mathematics, and we don't care about the physical interpretation, about the mechanisms. Okay? And so this fellow says, theories about the evidence, theories that move from the particular to the general. The requirement that contradicting evidence falsify a theory. Falsify? Falsify, again, is belief. It's opinion. What is false to you is true to me, and vice versa. Maybe God is true to you. And you say, God exists, and I have proof, and I have evidence, and I've convinced myself. And look at all the people who believe. Come to my church, and you'll see all the people who believe in that same God. And I have proof. And what's he trying to do? He's just trying to convert you. He's trying to produce evidence to persuade you to believe like he does. That's all he's doing. That's not science. And so every time someone talks about evidence or falsifying, Falsification only means that he's going to introduce evidence to try to show you something, to try to convince you that you're either right or that you're wrong, whichever, it doesn't matter. And we don't do that in science. We don't use falsification. That's not a criterion of science. It's a Popperian, Karl Popper, Austrian so-called philosopher, who introduced that, and everybody bought into that. But what is it? It's nonsense. Falsification only means that you're going to convince someone of something. It's easy to falsify, quantum mechanics. The guy says a particle can be at two places at once. Yeah, sure, show me that at the lab. How are you going to show that? It's something that you can't prove in any way, so it's an unfalsifiable proposal. Okay, but these people get away with that. They say, oh yeah, that's what we verified. Why? Because they do everything with particles. And yeah, when they can't explain it, they say, well, the particle was two places at once. And we're done. Yeah, so it works. So yeah, all this nonsense about falsifiability and presenting evidence has absolutely nothing to do with science. And these people are educated, actually brainwashed in high school, and some of them go up to college and they get further brainwashing, and this is what they repeat, and then the generation repeats the same thing, and the next one, and the next one, and the next one. That's how we got to today, because no one challenges these notions. They say, oh no, all the scientists can't be wrong. It's like saying that all the flatlanders can't be wrong, or flat earthers, or all relativists cannot be wrong. Yeah, of course, or all Catholics cannot be wrong. They can't all be wrong. How many we have? 1 billion people who believe in God. They can't all be wrong, can they? So this issue about being wrong and voting and introducing evidence and falsifying or using this falsification criterion has nothing to do with science. But this is what they've brainwashed people with, and that's what people repeat. Okay, here's another comment. However, it is gathered, evidence, however it is gathered, evidence must be unambiguous and repeatable, and it must be objective. Two impartial observers must come to the same conclusion. So, do we have a similarity of criteria out there? Has everybody come to the same conclusions? Let's see if I can find it here. Where is it? Here's quantum mechanics conclusions. Okay, this is from a group that follows Mr. Bohr, his disciples. What does he say? Here I have some ideas that come out of CERN, the complex over there in Switzerland, right? The LAC, Large Hadron Collider. And they have run experiments repeatedly. So we meet the repeatable criterion that he's proposing. And they have concluded that a particle can be at two places at once. Light is both a particle and a wave. And virtual particles pop in from the void by magic, at their whim, or at the whim of the mathematician's magic wand. And here you have irrationality from another quarter, which is the general relativity, and something similar. You have people like NASA and LIGO, okay, and LIGO were the guys who supposedly discovered gravity waves, okay, and they run, again, many experiments repeatedly, so we have the repeatable criterion. We've covered that one, right? And what have they concluded? Well, they concluded the Earth drags space around. Okay? Your space is nothing, and Earth drags it around. They allegedly proved that with gravity probe B and some other experiments. And they claim that there are some things they call black holes. Zero-dimensional objects. They have no volume whatsoever, no size, and these non-entities crush matter out of existence. That's what most people believe out there today. Dark matter, again, it's a concept that compels stars to travel faster. It's like saying love enables stars to travel faster. So is his criterion valid at all? I mean, what is he saying here? Is he saying that we should do repeatable experiments and reach the same conclusion? Well, here, I'd like to do that experiment all the time. Here's a pen, and I'm going to let go of it. Always falls to the floor. And here's another one, just in case, you say, well, it's repeat. Yeah, it's repeatable. Look, here, I'll repeat it. Yeah, I can repeat it all day long. Got a bunch of pens here. See, have a pen. Okay, same pen, by the way. Maybe there's a slight difference in weight, but whenever I let go, it always falls to the floor. So the experiment was repeatable, right? I can repeat it a few more times if that helps anyone out there, right? Do we come to the same conclusion? What conclusion? What's the conclusion? What is gravity? Have I figured out what gravity is by, throwing pens a million times? I mean, we've been throwing stuffs, baby spoons since the days we were born. And we still don't know what gravity is. We cannot explain gravity. In other words, they cannot explain the mathematical physicists cannot explain gravity. And yeah, and they never will, because first they're using particles, second they're using equations, and third they're running experiments ad nauseum. So what? You ran an experiment. What did you prove with the experiment? How are you going to figure out something that is invisible and intangible, such as the mediator of gravity? You're not going to figure out by running experiments. The way you do it is the way I do it. You grab a beer, okay, and, excuse me. Grab a beer, sit back, put your feet on top of your desk, and you think. You try to visualize what Mother Nature could be using as a mediator for gravity, for magnetism, for electricity, for quantum jump in the case of the atom, and all these invisible things that we have out there. And once you visualize that, then you can explain. You can explain how the mechanism works. But if you're just going to go to the field and do an experiment on what? What are you going to do? We know gravity by heart. We know what gravity is. Things fall to the floor. Just explain why. Doing another experiment will give you an insight? No, of course not. So it's not an issue of running experiments ad nauseum forever. Okay. Here's another comment. They have comments again. Had too many of those. And this has to do with, he made a comment, this individual, on bias crackpot index. He says, the aim of this is not to stop the development of new ideas, but to eliminate crackpot ones that are inconceivable or impossible based on current knowledge. Well, I just mentioned a couple. I mean, are these crackpot theories or am I wrong? I mean, here's Einstein and his general relativity. Are those crackpot theories? The Earth drags space around itself. Black holes are zero-dimensional so-called objects. Actually, no object there, because an object is that which has shape. And this nothingness crushes matter out of existence, has infinite mass. Is that the current knowledge? Is that a crackpot theory? How about dark matter? I mean, here's a concept that compels stars to travel faster on the outside of a galaxy. It's like saying love or intelligence forces stars to travel faster. Are those crackpot theories, or should we consider them as such? And here's, quantum mechanics. Are these crackpot theories? Here we have a particle can be at two places at once. Is that crackpot, or is that mainstream? Is this knowledge? Light is both a particle and a wave, so-called wave packet. Virtual particles pop in from the void at their will. I mean, are these the crackpot theories he's talking about? So yeah, people have made up their minds that whatever comes from the establishment has authority, has a PhD degree behind it, right? And so they say, no, we can't question that, because see, all these guys, they have PhDs, they all agree. So we're not going to question that. We're going to question the lone gunman out there, the little outlaw who's rebelling against all these people. It's not a question of, or like I think it was Galileo who said, like, the revolutions are created by one guy. They're not created by a team. It's always one guy who comes up with the first idea, and that's the idea that finally gets spread around. Sometimes it takes a long time. But, a million people can be all, for all we care, Down's patients. It's going to be the smart guy out there who figures it out. And so to say that all these guys with PhDs are going to figure it out when all they do is repeat, parrot whatever their teachers gave them, because it's the only way they're going to advance, then yeah, I mean, we're going to get the same thing over and over and over again. We're never going to make any progress, and that's the status quo today. Okay, here's another comment. Okay, and it goes like this. Bill's notion of single thread as explaining all matter in the universe may seem by some as a crackpot idea. Well, okay, why? What's crackpot about it? I mean, is it any better to say particles? A rope which physically can move objects, as in the case of magnetism. Well, can you do it with particles? I mean, that's what quantum proposes. Can you do it with space-time, a concept? Can you do it with that? Is that crackpot? So again, these people like to use these words to try to belittle a theory because it's new, because they never heard of it, and it shocks them. And they say, no, we've always done it like this. We've done it with particles, and we've done it with space-time. Are those any better? Are those any better than flat Earth theories? I mean, why particles? How can you pull with a particle, which is the only force that quantum mechanics cannot explain? You can't pull with particles. You can't throw particles and pull the donkey. Try it. Try it in the field. Do an experiment. You like to do experiments? Go ahead and do the experiment. And then it says, I can place a magnet on a table and move a metallic object underneath that table, yet I can't touch or cut that rope. He's referring to the electromagnetic rope, which is what we're proposing. It's not the rope in the case of magnets, it's called a thread, but he can't tell the difference. It's just worse. Worthless time spent on people like him. If he doesn't know the difference between the rope and the thread, he keeps using the word rope. The ropes go through each other and they never appear to get tangled. Well, that's easily addressed, okay? Let's see if we can get this in here. So many of these. Okay, and here it is. I mean, is an object that which we can touch or see, which is what this individual is trying to do. He's trying to see and touch. He says, I can't touch or cut the rope, okay? And he obviously can't see it either, right? Can you see the air? Can you touch this hypercube, which is a four-dimensional cube proposed by general relativity? They go through all this nonsense about hypercube and hyperspheres, right? Concepts. And you can't touch a concept. It's very hard to touch love. It's very hard to touch information, but you can't see the air. I mean, that's quite obvious, I think, right? And if you can't touch the air, does that mean air is not an object, not a thing? Is air a concept? I feel it, but I'm touching a concept just because I can't see it. Thank God, Mother Nature was smarter than this guy, because, she made air invisible. Mother Nature got together with God and with Father Universe. All three of them got together and they said, look, we're going to make some humans dumb, but we can't make them all blind. That would be horrendous. Even the devil felt that it was a bad deal to do it that way. So they made air invisible. And, so because air is invisible, it doesn't exist. It's not there because, we can't see it. I don't know what's going inside my mouth. So yeah, these people think that an object is that which you can touch. And no, we say an object is that which has shape. Okay? Now, the fact that it has shape on its own without us seeing it, doesn't rule out. Shape is not that which you can see, and shape is not that which you can touch. Shape is a different criterion. In fact, see and touch require a second object. Okay, so yeah, you can't use what he's trying to do there. He's trying to use his senses, especially accept the common sense, right? He's trying to use his senses to figure out how to what invisible entities Mother Nature uses to do magnetism in this case. Okay, and here you see the electromagnetic rope. Okay, and is that an object? I mean, do you see something there that has shape? Does it have shape? What I'm showing you there. Okay, and here I can show you here. This is the rope. Does this thing have shape in your opinion? You might say, whoa, what is shape? People get into these endless debates on what is shape. Well, it's very simple. If you have trouble, if you never went to kindergarten, never learned shapes, go to kindergarten today and, I have a cube. See if I can let me get this one out for a second here. Okay. Here's a cube, Rubik's Cube. That's the best I could do. Okay. And here's a sphere. Okay. Just a ball. Okay. And the question is, let's assume these have the same volume, the same color, the same material, the same everything. Right? You go to kindergarten, you ask the 5-year-olds, okay, at least, maybe 6 years old, I don't know. And you say, look, what's the difference between these two? And I'm sure they're all going to, the shape. Now you learn what shape is. So if you don't know what shape is, just go to kindergarten and the kids will teach you. They'll teach you what shape is. Because people seem to have trouble after they go to college understanding what shape is. But that's not the point. The point is that shape is the criterion because it's a universal criterion. Okay? And none of the others, volume, mass, that which you can touch, which you can see especially, none of those qualify as a proper definition of the word object for the purposes of physics. That's the issue. The issue is we don't need to know what shape is. We just need to know the difference between shape and running. Are we going to say that which moves? Is that what an object is? No, because running requires several frames. You have to define object before you define verbs. And so we're comparing a shape against running. We're comparing or verbs. We're comparing shape against see, touch. We're comparing shape against mass. So all we need to know is which of these criteria you're going to choose as the criterion to define an object for the purposes of physics. That's what it's about, okay? So it's not an issue of saying, oh, what is shape? No, you don't have to go that far. All you need to know is the difference between shape and running. If you can't tell that, well, go back to kindergarten. That's all I can say. And do the experiment. See if you can figure out what shape is, okay? Anyways, the other issue there was touch. This guy seems that we can't touch it. Well, here, let me enlighten you a little bit on touch since he's such a smart individual, right? Okay. Touch is zero distance. That's what touch is. Okay. Now, if there's more than zero distance, like in that first case, you have two objects. But the problem is that when you have zero distance, all you have is one object. The two objects have become one. And then you don't have any distance, and then you can't talk about touch. Okay? Now, I know this is over your head. All I can say is define touch and then come back here with your question. Okay? Try to be smarter next time. My God, some of these people. Yeah, before you can cut the rope, you got to touch it. If you don't know what touch is, well, then you got a lot of investigating to do before you can criticize the rope hypothesis. There's a lot of stuff that is included in the book, and you just got to find out what the arguments are. They're over the head of most people here, so we'd rather not touch upon that here. Okay? Yeah, we do have criteria for touch, why ropes go or don't go through each other, how it does that, how Mother Nature does that magic trick. Okay? And these are things we try to talk about, but not here. Because some people can't even handle the kindergarten stuff. They don't know what shape is, and they don't know what an object is. They don't know what exist means. And if you don't understand those words, which are key words in physics, then there's no use in talking about something more complex. Here's another comment. Okay. Says, since Bill likes to show movies to demonstrate his mechanism, I asked Bill, please show me a physical, not a conceptualized rope that has these properties. Okay. And he says he can't because it doesn't exist. And moreover, he says, you have to assume that it exists. Well, Bill, the assumption is incorrect. Okay. Let's continue to investigate until we get ever closer to discovering the mysteries of the universe. Well, not only are we not closer, we'll never get any closer. We're not even close. Because in 3,000 years, no one has figured out how magnetism, gravity, etc. work. And they won't, because no one's investigating any of that. Like Bias just said, they're not doing mechanisms, first of all. Second, the other people say, we don't understand our own theories. We don't know how it operates out there because we can't see anything. We're blind when we deal with these things because none of these things are touchable or seeable. They're intangible and invisible. You can't figure out gravity by running an experiment in the lab. And, you know, some people with tiny brains, they don't understand what I'm saying. So let me try to say it again. Maybe someone out there, you know, it brightens their mind a little bit. You can't figure out gravity or magnetism, two invisible mechanism. You can't figure them out by running an experiment, doing equations, or mediating them with particles, with discrete particles, or particles which are not particles, like in quantum, which are vibration of fields or whatever. You can't do it. And unless you come to grips with that, you know, you're in the wrong channel. And yeah, one of the good things about this channel, it weeds out the riffraff. When people find out, you know, what this channel is about, this scares me because they're not used to it. They're used to all the nonsense they hear from, you know, the big celebrities out there. And so when they come here, it's like a shock, cultural shock, okay? Scientific shock, I call it. Okay, so yeah, some problems here and there. Here's another comment. I guess it's the last one I'm going to deal with. We're going to have to deal with good old Aristotle and Euclid some other time. I can show you a black hole, an atom, and light. Oh man, I would like to. I don't want to see your black hole for sure, but but I guess he's referring to this. Where is it? See if I can get it here. It is this image which a group of so-called scientists came up with. And there's two, if you go to the, well, you can look it up almost anywhere, but I put two articles. One is from Wired, the other one from BBC News, and they both tell you that this was done by a team of people over a period of days. You're not looking at a photograph. You're looking at a collage. That's the first issue. And he thinks it's a photograph. Oh, they took a picture. Well, we got to see how they took that picture. What is that picture? It's like when they show pictures of atoms, people say, in fact, he sent one of those as well, you know, what is an atom? And people get the wrong idea. They think that these investigators out there, these researchers, that they have photographed an atom. They have this idea because they see an image of an atom and they say, oh, look, oh, it's so awesome, you know. They took a picture of an atom. No one has taken a picture of an atom. You're a fool if you believe that, okay? No one has a picture of an atom, and I'll prove that. You want proof? You want evidence? Okay, we'll give you proof and evidence. Here's proof and evidence that there is no such thing as atom, that nobody's taken a picture of an atom. Okay, this is the atom we have today. This is the one that's used by everybody to explain ionization and electricity. It's known as the planetary atom, invented by Mr. Rutherford and Bohr. That's the one in use today. And then at the end of the show, the mathematician tells you, oh, by the way, that's not our atom. Don't take it literally. It's like an analogy or whatever, okay? You're not supposed to take that one literally. But that's the one they use to do other things. That's the one they use for ionization. They say the electron flies away, and electricity is the flow of these electrons from one atom to another. So that's how they explain it. And the only thing they have to explain, because see that ring there, that's not a hula hoop, okay? That's the path, okay? It should be, see, they don't paint it right, but they should paint it with dotted lines really to indicate that that's a path, that's an itinerary. And the only thing that anybody has to answer is what keeps the electron ball, okay, tied to the nucleus. What entity is there between them? What physical entity is there between them? And if you say, well, there's none, then you're putting angels, you're putting spirits in there, in that same space, because you're doing it with magic. You're not giving me a mechanism of why the electron bead doesn't fly away spontaneously before you ionize or produce electricity. So this is where quantum mechanics fails miserably. It can't answer, and it never will answer, because you cannot explain pull between two particles with particles. I don't care what you put in that space between the red and the violet particle there. You can put particles, you still will not be able to explain the mechanism of attraction. Particles can't pull. So what are you going to put particles on the outside pushing the electron bead inwards? What happens to those particles when the electron bead flies away during ionization and electricity? So we have a problem. We have a problem because this is nonsense. And at least the quantum mechanics, a lot of them at least, acknowledge that this is a nonsense picture of the atom. And so this individual, he says that he can draw an atom, and he sent me to I don't know where. No, I want you to draw an atom. Show me a picture of an atom anywhere on the internet. Of one atom, I want to see the electrons, I want to see the protons. You can use a s orbital, you can use a p orbital, a d orbital, I don't care which orbital you want to illustrate. Illustrate an orbital and show me what your atom looks like. And the best one would be this one, the hydrogen atom. Very simple. And regarding, he says he also can draw a picture of light. Well, all I can show you is what we have today for light. Okay, and here it is. These are the notions, these are the pictures that, or the ideas that people have of what light is. Some people say it's a flow of particles, electron beads, or photon beads in this case, photon beads, or maybe it's a transverse wave. So which one is it? Aside from the fact that a wave, a transverse wave, is a bunch of vectors. That's all those little engine arrows are. So there is no such thing as a wave. There's no physical object called a wave. And then one guy, at least, illustrated in his book, high-level guy, the wave packet. You know, that curlicue, it's with an arrow, engine arrow going through it. It's a bed spring with an arrow. This is the notion that the mathematicians out there have of light. So if you have a better one, show me a picture of light. He says he can draw light, he can draw an atom, he can draw, what was the other, black hole. Okay, I like my vision of the black hole better. Let's see if I can find it here. I think you'll like this one. Where is it? Give me a second here. Here it is. Okay, so this is really the best picture that you'll find of a black hole. If I can get it up there, Jesus. Give me a second here, so I prepare it right. Okay, here it is. That's the black hole that they took a picture of. And again, is that a black hole? Is that what we call a wormhole there? And we like, yep. That's what a black hole is. That's all the suckers whoever believed in black holes. Okay, you really got to be have a big problem in your mind if you believe in a black hole, because the black hole has never been defined. And that's what these people don't understand. There is no definition of the term black hole. And they define it as a region. Region is not a physical object. And here they say this region has so much mass that it moves stars around from a distance. And even if that were true, which is nonsense, but what's the mechanism? Show me how mass brings that star over. And what have they invented? They invented the field. You know, you bend the field. You know, you want the football to come rolling towards you, but what you do, you curve the field over and the football falls to your hands, who's in the depression. So that's the mechanism these individuals have come up with, because they have no other way of explaining this. Okay? And so, yeah, we think all of mathematical physics has only irrational explanations. It's not science, and that's why we need to change all this. We need to get rid of mathematical physics completely. Anything from Newton onwards is garbage. Let's get rid of all of it. Anyways, we'll see you on, Sunday. Hopefully I can get back to good old Aristotle and Euclid, okay? Just so many questions that pop up. So we'll see you Sunday. Bye-bye.